In this video, we're going to walk through a demonstration of Dell EMC's Isilon Scale-Out NAS. My name is Brian Summers, and I'll be your presenter for this video. Before we get started, make sure you take note of the related Isilon resources here on the bottom right of the slide. Those are several useful links for materials and resources that I'll be using throughout this demo. And you'll also find some things there that I used in the overall Isilon presentation video, which is also a part of this YouTube playlist. So again, just a reminder, the first link there, Isilon Weekly, is so you can register for a live weekly demo. The playlist link is the one you're using right now. So if you're watching this video, it's a part of the Isilon playlist on YouTube. And the simulator download is something you might find interesting after watching this video, because I'm going to use the Isilon simulator to actually walk you through a demonstration of the web user interface. And you can download the simulator as well if you want to follow along. Then the last three links there, if you're a big nerd like me, you might also want to dig into the admin guide for Isilon ONEFS and take a closer look at the Isilon hardware. So check out those links. Again, those are down below in the comments, and let's go ahead and dive in. So the agenda for the demo is to go through and show you some pretty basic features of Isilon that really differentiate it from a lot of the other platforms out there. We're going to see how we access the cluster and do all the other things that you see listed here. And the reason I have the heading plain English there is a lot of times you're going to hear some corporate marketing speak associated with these activities. So when I talk about accessing the cluster, specifically with Isilon, we like to tout the fact that we support multi-protocol access. That just means you can access the cluster from Windows, Linux, Mac, Hadoop, you name it. There's all these different protocols you can use to access the cluster. The second bullet point there, provisioning storage. If we translate that into corporate marketing speak, that's a feature called Smart Quotas. So we'll see here in the demo how we use Smart Quotas to provision storage for users and applications. The third one, where I say we're going to review the protection level options, that again translates into the fact that we use erasure coding instead of RAID. And I guess that's more of a techno speak than a marketing speak. But at the end of the day, we'll review our protection level options, and that has to do with a technology called erasure coding that we use instead of RAID. We'll also see how we protect against human errors and disasters. We'll use a feature called Snapshot IQ to create snapshots to protect against human errors. And we'll also talk about Sync IQ, NDMP, and antivirus. Those are all three things with an Isilon platform that can be used to protect against disasters. Then lastly, this is just English to English. So we are going to see how to add capacity and performance by simply adding a node. So if you recall from the previous overview video, we talked about the nodes being analogous to horses. We'll see what it looks like to add a horse and just see the cart get bigger. So that's the agenda for the demo. Before we get into the demo environment, I want to give you a quick visual overview of that environment so you know what we're doing once we get in there. So here on the far left, we've got our users and servers maybe running Windows, Linux, Mac, etc. In the center there, we've got our local area network where we're using those file protocols that we talked about in the previous video. And then, of course, on the right-hand side of the slide, we've got our Isilon cluster. Now, when we get to the demo, I'll point out that we've got 4 nodes. So those 4 servers there are the nodes we're talking about. I'm actually going to simulate a Gen 6 scenario where we look at our simulator in the context of Isilon Gen 6 hardware. But the principle still applies here. You're looking at 4 nodes. And specifically in the environment, there's going to be every device in the environment is going to have an IP address that begins with 192.168.199. And then my clients over on the left are .10, 11, and 12. And we're going to see how those clients connect to this .20 address in order to connect to Isilon. And what's going to happen when we connect to .20 is that connection is in turn going to get relayed to an individual node. So in this case, .21 represents node number 1. The next connection is going to come in maybe from a Linux machine. That's again going to go to that .20 address, which in turn is going to get brokered and sent over to the second node. So .22 in this case. And then just follow the pattern. The third machine can come in, connect to .20, and then that's going to go to node number 3. And then let's say we come back around, another Windows machine wants to connect to the cluster. It's going to go to node number 4, and so on and so forth. So what I'm illustrating here is that regardless of what types of clients and how many clients you have on the left-hand side of the screen, those connections are all going to be load balanced automatically across all the available nodes. So you don't have a situation where all clients and all devices are connecting to just one node or the other. And that's all made possible by this, what we call Smart Connect IP address, or Smart Connect technology. And it's just a virtual IP address that allows exactly what I just described, the load balancing of all those incoming connections across all the available nodes. Now we actually take it a step farther, and we also allow you to map a fully qualified domain name to that IP address. So in this example, I'm showing you onefs.dellemc.com. But in the case of any customer, they might have a name like myisilon.mydomain.com, etc. So we'll see how we access the cluster, and we'll talk about some bookmarks as we go through that. And I wanted you to have some context for what those bookmarks were about when we start talking about them. So that's the lay of the land for the demo. We're going to jump in now over here in VMware Workstation. So to give you the lay of the land here, this is the Windows machine I was just showing you in PowerPoint. And then down here in this OneFS folder, I have 4 nodes. So this represents those 4 nodes that we were showing you in the PowerPoint slide a minute ago. What I'm going to do is access all those nodes directly from the Windows machine using Chrome. So from here on out, I'm just going to go full screen. And now you know a little bit of the secret behind the covers. So here in Chrome, you can see in my address bar, I've navigated to the friendly name that we mentioned in PowerPoint. And that's, in my example, is onefs.dellemc.com. So again, if this were an actual customer implementation, that might be something more like mynewIsilon.mynonprofit.org or whatever it might be. So just a user-friendly name for the environment. Now what's really happening with this address under the covers is it's connecting to this Smart Connect IP here, the .20 address. And that in turn, when we connect to it, is relaying the next connection that comes into the system is being relayed to the next available node in the cluster. So what I'm showing you here is a little bit more than any users in the environment would know about or even care about. But as a storage admin, what you should take away from this is you have the ability to connect directly to any individual node for admin purposes. But at the end of the day, your users and even you on a day-to-day basis are going to connect to this single Smart Connect IP, and that's going to get you to the cluster. And then if you want to take it a step farther, you can also set up this user-friendly name like I've done here. So that's how that works. So let's connect to that .20 Smart Connect IP address. And that's going to take me back to this login page again. I'll log in with my root credentials. When I log in here, you can see that it happened to connect me to node 1. But again, the next time around, it might connect me to node 2, 3, or 4. So the fact that I'm connected to node 1 is arbitrary, and I don't have to really worry about which one I'm connected to. And I say that because if we look at the lay of the land here, we see by default, we land here on the cluster overview, and we see all 4 of our nodes. So I've got nodes 1, 2, 3, and 4 right here. And there's those IP addresses for the individual nodes that we talked about in the PowerPoint slide. So regardless of which node I'm connected to, I can see and access everything. And more importantly, while I do have visibility to the individual nodes and their statistics, so I can go here and look at node 1, for example, and see statistics around throughput, used space, actual data being stored there, available space, etc. While I do have that visibility, as an Isilon admin, I'm going to spend the majority of my time down here at an aggregate level looking at the totals. So I can see that my cluster has 4 nodes. I can see my total input and output amounts to about 3 megabits per second. And then if I look over here, I can see that I've got about a little less than 2 gigs of data on my cluster. And then all in, I've got 75 gigs of space available to me. So the key takeaway here is right here on a landing page, you've got full visibility to all the available nodes in the cluster. You get a nice pie chart that gives you a readout on used versus available space. You get a quick glance at cluster throughput, CPU usage, etc. It's kind of your home base, if you will. So what I'm going to do to start with is illustrate kind of the benefit of having that back-end network we talked about in the overview video. So to do that, what I'm going to do is I'm going to go ahead and intentionally fail node number 4 I'm going to remove that from the cluster. Might be many different reasons you do that. Maybe it's just time to retire it because it's up on maintenance and you don't want to renew. Maybe you want to remove number 4 because you're on the phone with tech support and they ask you to take it down for maintenance reasons. Whatever the reason is, we're going to go ahead and do that. We'll come here to cluster management. We'll go to hardware configuration. And when we get there, we're simply going to click on the more option out here next to node number 4. And we'll click on smart fail. And then that's going to, if I come back here to the overview, that's going to put node number 4 in a smart fail state. So here you can see node number 4 is being smart failed. And all that really means is we're going to take any data that's currently on node number 4 and automatically balance that across the remaining 3 nodes. And then when that's done, we're going to go ahead and take number 4 offline. So the point here is that I'm removing an entire node from my cluster and it's non-disruptive. Now the common question I get here is what happens if you just pull the plug on node number 4 as opposed to gracefully shutting it down like this? And the answer there is all the data that's on 4 has parity bits written across the other 3 nodes. So that data would just be immediately rebuilt elsewhere in the cluster and would also be accessible elsewhere in the cluster. So that's what happens. So that's failing some hardware. While that's happening, let's get into the basics. So in the overview video, I talked about how 1FS stands for one file system. So of course, the natural place to start would be to look at the file system. So if we come here to that menu and we look at the File System Explorer, this is how we can go look at the file system. So as an Isilon admin, I would come here. I see some default folders, root folder of IFS for 1FS, a snapshots directory, etc. I can go in here and create a directory. Let's call it my new amazing directory. There we go. And I've made a folder. And now at this point, I'm still wearing my admin hat, not my user hat. So as an admin, what if I wanted to manage this from Windows Explorer, from native Windows tools, instead of working in this web interface? To do that, all I would do is simply open up Windows Explorer. I'd come right here. We can put in that user-friendly name, 1fs.dellemc.com. We can find the directories that we've created, and here we can see there's my amazing directory. So in there, I can, with this in mind, I can now work directly from Windows Explorer or any native Windows tools I'm used to using to manage these files and folders. To switch gears and put on my user hat for a minute, if I'm a user in this environment, then everything I've shown you up till now, I don't know anything about. What I would see as a user is the admin would have provisioned a network drive for me. So let's go here and let's call this let's call it the iDrive for Isilon. So from an end user perspective, what I'm going to do is I'm going to come in the morning and log into my computer, this PC, and I'm just going to see under network locations an icon here for my new amazing directory, right? And I'll pop in there and let me go ahead and create some super duper important business documents here. Boom, boom, boom. So now I'm starting to write data out there. So at this point, what I've already shown you is accessing the cluster from Chrome. So that would be using a web protocol. And here in the foreground, I'm accessing the cluster through Windows Explorer, which is through a protocol known as SMB. And the point here is I could be on a Mac machine connecting into the same directory. I could be on a Linux server using the NFS protocol. I could be on any number of devices using any number of protocols, accessing the exact same files and folders. So this is what we're talking about with multi-protocol access. It's really a big deal at the end of the day because what this does is allow businesses to create a single data lake, a single big repository to put all their unstructured data such that users, applications, modern, new cutting edge analytics programs, etc., anything can go access the data because it's all in one place. So that's multi-protocol access. So now that we know how to access the cluster, let's take a look at what we do to protect against losing this data from hardware failure. So I mentioned a few times in the overview video that we use something called erasure coding. So let's go see where that is. If I come here to File System and look under Storage Pools and look under File Pool Policies, here you can see I have a default policy. And if I hit View and Edit, there's a drop down here where on a traditional scale-up platform, you would see a list here of things like RAID 1, RAID 10, RAID 50, etc. Here, though, what you see are erasure coding protection levels. So when you see something like 2D1N, it tells you in plain English that that means if I pick this protection level, I've set up my protection such that I can tolerate the failure of 2 drives or 1 entire node. So right off the bat, the first obvious difference between erasure coding and RAID is when you pick your protection level, you know what you're getting. You don't now have to go to Wikipedia and look up a reminder on what that RAID level gets you. So it's plain English, easy to understand. The second big thing that makes erasure coding a much better option for RAID in a scale-out architecture is this is what allows us to start as small as 20 terabytes and grow out a single namespace to as much as 60 or more petabytes. Not something you can do with RAID. And then the third thing that makes this thing a big advantage with erasure coding is I can change to and from any of these protection levels at any time, and it's completely non-disruptive to my users because this protection is applied to the data, not a physical set of disk. So we're applying this to the data as it comes in, and it's not bound to a RAID set or a finite set of spindles. We use all the available nodes and spindles in the cluster, and we protect the data accordingly. So that's erasure coding. In a nutshell, that's what we do to protect the data against hardware failures, and that's why I was able to fail node number 4 a minute ago. So now that we can see how we protect against hardware failures, the next obvious thing would be how do you protect against human errors? People delete things all the time, and how do you recover that stuff? And as with any good storage platform, we do have snapshots, and we call that Snapshot IQ. And at the moment, you can see there are no snapshots. And if I come back here and look at this from the user's perspective, I'll go back to this PC. I'll go look at the properties for my new amazing directory here, and you can see there are no snapshots there from the user's perspective. But if I come back in here as the storage admin and I click Create Snapshot, I can browse out to that directory. There's my new amazing directory. And I can choose to expire these if I'd like. So I'll just say this expires tomorrow and hit Create Snapshot. So immediately I see that snapshot here in the admin interface. I could have also scheduled that snapshot by coming here to the Schedule tab. But for the sake of the demo, I'm just going to work with this manual snapshot here. Now again, if I switch gears back to the user's perspective, this is their new amazing directory. And this is the properties we were looking at just a second ago. And if we close and reopen those properties, now you can see they have a snapshot. So at this point, what you've got is their production directory here. And if they happen to delete everything, so that's all gone, they can simply come here and open their snapshot side by side with their production folder and put everything back. So if you're looking at this thinking, Brian, that looks a lot like Windows Volume Shadow Services, that's because that's exactly what this is. So at the end of the day, because I happen to be working with a Windows machine, we're leveraging the native capabilities and protocols of a Windows machine to manage snapshots. I could also jump in here and individually grab files and folders and put them back as well. But the point here is we'll do the same thing with Linux and Mac. Whatever those native capabilities are and their native protocols, we enable snapshots on those machines and recovery of entire directories and individual files. The same on a Linux as we do for Windows as we do for Mac. So kind of universal snapshots, a huge benefit to having one file system in the environment. So that's how we protect against human errors. The next thing is, what do you do to protect against disasters? And that comes down to these three options here. We've got Sync IQ. And to demonstrate this, I would need a second cluster, and I don't happen to have one handy. But basically, you could create a Sync IQ policy that replicates your snapshots from your production cluster to a secondary cluster that's hopefully far, far away. And that's what the majority of our customers do, because we've moved on past tape for the most part. But we do still have customers that prefer to back up to tape. So for those customers, we support the NDMP protocol. And you could come here and create policies to enable your backup software to reach into the Isilon file system and back up that data to tape. It could also back up directly to like a disk-based target, such as data domain. So that's NDMP. And then with antivirus, we don't have our own antivirus software, but if you have a antivirus server in the environment that supports the ICAP protocol, ICAP, then you can use that antivirus server to scan the 1FS file system. So that's what we do to protect against disasters. So the next thing we'll take a look at here is how to provision storage for users. So looking back over here at the user's perspective, if I change the view up a little bit here, we can see that this user sees 56 gigs of available space. Now the reason I point that out is that happens to be the total capacity of my cluster. And to see that from the admin's perspective, if I come back here to the dashboard and overview, then I can look here and see down here in the totals row, I have 56 gigs of space available. So as an admin, I don't want this user to have access to the full capacity of my new Isilon cluster. So let's say for this example, we only want them to have access to 2 gigs of space. To enforce that, I would simply come back here to the web interface, go to Smart Quotas. I'll click the little blue button here that says Create a Quota. I'll browse out to that directory. You could also base this on users and groups if you're authenticating to Active Directory. But for the sake of the demo, I'll just base this on a folder. And then I'll specify a storage limit. And I'll come down here and set a hard storage limit of 2 gigs for our example. So there's 2 gigs. And then as soon as I hit Create Quota, and then come back over here and look at this from the user's perspective, you can see now he only sees 2 gigs of space. So that's how easy it is to create a quota for a file share. But it's just as easy to change a quota. So if you decide later on, oh, I really need to give that user more space, you just come back in here and hit Edit, come back down to this window, hit 4 gigs, whatever you want to give them, and that takes effect immediately. So the key here is that it's very simple to do, it's very simple to change. It can indeed be based on users and groups, so you can set these quotas using native tools that you might already be using for LDAP or Active Directory. And this is, in the example I'm showing you here, I'm talking about users and home directories and that sort of thing. But this could just as easily be a share created for your video surveillance or for your PACS medical imaging, or you name it. So you can create and provision storage for any number of use cases. So that is what we call smart quotas. And then what we're going to do is wrap up here by coming back to the overview. And if you recall, we started with 4 nodes and we failed out node number 4 at the beginning. And I did that just to demonstrate that while that was being failed out of the cluster, nothing was disrupted. We didn't lose any data, we didn't lose connection to the cluster, etc. But now let's switch up the scenario and say it's been a few years and I want to add a node to a cluster. Or maybe I've wrapped up my tech support case and I want to add node number 4 back. To do that, I just come here to Cluster Management. I go down to Hardware Configuration. And from here, I click the little blue button. So if you notice, there's a pattern. Once you get to where you want to go, you just click the blue button. And I check off the box for the node that I want to join into my cluster. Now for this node to show up here, it needs to have already been racked and stacked, of course, and cabled into that backend network that we talked about on the overview demo. But once that's done, I just check the box here and I click Add Node, and that's the end of the process. Now if we come back here to Cluster Overview, we can see that node number 4 is going to be red at the moment. So there it is, red. But here in just a few seconds, you'll see that an additional 18 gigs of storage will come online. We'll pick up an IP address. And more importantly, this used space, this actual data here, will start to get automatically balanced across nodes number 1, 2, 3, and 4. So again, we're auto-balancing that data. So if you recall, when we removed number 4, we balanced that data across the remaining 3 nodes. Now that we're adding it back, we're rebalancing it across all 4 nodes again. So this auto-balancing capability is enabled by OneFS, combined with that back-end network that we talked about. Now this is important because from a real-world perspective, what this means is you're now able to add and remove nodes over time. So you can add nodes if you need more horsepower or more capacity. You can remove nodes if you have a node that's out of maintenance and you just want to retire it. So you can add and remove nodes non-disruptively, and you can do that at whatever cadence makes sense for your business. As opposed to that scale-up approach we talked about, where every few years, if you're adding more data, then you got to throw out the old horse and get the new horse kind of thing. Never have to do that. So no forklift upgrades, no manual data migrations, no having to schedule maintenance windows and send out those emails to your users to say this storage is going to be offline at this time, blah, blah, blah. So that is what it looks like to add storage to a cluster in 60 seconds. And as you can see here, the data is already starting to balance across node number 4. So that concludes the demo. Let me jump back over here to the slides and leave you with a few reminders. So take a look in the comments down below or in the description of this video. You'll find these related Isilon resources links. And that is it. That's your one reminder. So I appreciate your time. Thank you for watching. Have a good day.